and thank you for coming to our presentation on how you can use embedded event manager scripts or EEM scripts and Python scripts to enhance your ability to troubleshoot problems in your network. I'm JeffRiehle. I've been a member of the core architecture team for about 4 years now. This is my colleague Arturo.
Hi everyone, my name is Arturo Obregon, and like Jeff, I've also been a part of the core architecture team for the past 3 years. So hey Jeff, why don't you walk us through the agenda for today?
Okay, so for the next 30 minutes, we're going to go over the use cases and benefits of using these tools in your network. We're going to talk about what EEM scripts are and how you can configure them. Then we're going to talk about Python and how you can deploy Python in the guest shell on your iOS XE switches and routers. Finally, we'll go over how you can combine Python scripts with EEM scripts and provide a couple of examples. Now, in order to understand issues in your network, you need to be able to collect data when those issues are happening. However, many issues can be intermittent. They're random. You don't know when they're going to happen, and that can make collecting data when they happen difficult. Worse, some issues can be brief. By the time you get an alert that an issue is happening and you connect to a device, the issue's over, and you're not able to collect data in the problem state to understand it. Worse, some of these issues can even interrupt your ability to connect to the device in the first place to be able to collect that data. What we need is a way to trigger on events when they happen. Now, I'm going to go over an example here, and while we're going to talk about a few specific scenarios, I want you to focus less on the specific issue we're talking about and focus more on how these tools can be used to troubleshoot issues in your network. Now, with the core architecture team, we often see cases for high CPU. And if you look at the graph here for this customer, it looks like they were seeing high CPU over the last 72 hours. But if we were to zoom in on the 60-minute graph here, you can see the CPU spikes were happening less than a minute at a time. And that makes it difficult to be able to collect data right at that instant to understand what's causing those high CPU spikes. What we needed was a way to trigger on that high CPU event so we could collect the data that we needed to understand the high CPU. And then we need to be able to store that data for later review. We were able to use a tool called the embedded event manager scripts. We were able to trigger on that high CPU, collect outputs related to high CPU, and we were able to identify that the high process was BGP. Then, knowing that, we were able to refine the outputs we were collecting with this script. And during the next event, we got more information, and we were able to isolate the problem to routes being added and removed to the routing information base due to a neighbor flap further down the network. My colleague Arturo will tell you more about the EEM scripts.
Thank you, Jeff. As you just saw from his example, EM scripts can prove to be a very useful tool when troubleshooting time-sensitive networking issues. However, you might still be wondering, but what exactly are they, and more importantly, how can I implement them? So let's start from the beginning. EM stands for Embedded Event Manager, and it's a powerful tool that is built into the CLI. It is available across multiple Cisco operating systems, such as iOS XE and NXOS, although for the purpose of this presentation, we're going to limit the scope to iOS XE since it is the most commonly used operating system within the enterprise branch solution. Now, EM scripts follow a similar structure to a regular programming script in the sense that we are going to be carrying out a specific set of instructions in an order predefined by us, and that we can add additional logic to it as needed, like if-else statements if we're looking for some decision making, perhaps some while loops if we're looking for iteration, or even variables if we want to save a specific value and then later on retrieve it during the execution of the script. However, the key difference between a regular script and an EM script is that we're able to define a trigger in order that we can initiate automatically. If you remember back from Jeff's example, back then he used the event of the CPU spike to initiate all the data collecting process so that he was able to gather the information regarding BGP and save that information. However, this is not the only option available. Let's say, for instance, that you want to save a backup of your configuration, perhaps on a daily or a weekly basis. We can think of using, for that case, instead, a timer-based trigger so that the information is saved accordingly. Now, once we have defined the trigger, we can then move forward with the actions, which is basically, what are we going to do with this script? Here at TAC, most of the times we are going to be using it to save issue a lot of show commands, as well as to save additional information, starting or stopping additional tools like a via trace or perhaps a packet capture. But this is not the only option available. Additionally, we can implement different forms of alerts, like for instance an email or a syslog message, or as well as an SNMP trap, if we want to alert us as users whenever a specific value is out of bounds, or perhaps when we reach upon a certain point during the execution of the script. Let's take a closer look at the structure of an EM script. Here you have an example of a small EM script that is going to be used to monitor memory usage. So first we're going to be having the name of the script in order to clearly identify it, followed by this authorization bypass. This is an important line of code if you have AAA configuration on your device. The reason is that a lot of the show commands or the tools that you may want to issue during your VM script might not be available unless you have a certain level of permits or as associated with a specific username. So either at this point we need to specify that username that does have the permits in order to issue all of the EM script, or we can issue this authorization bypass as, well, the name implies, bypass the AAA configuration so that you ensure that your EM script runs smoothly. So a tactic for you is if you notice that your EM script might not be running, this could be a good starting point to check out to make sure that you have the proper AAA configuration. Once you have set it, we can then move forward with the triggers itself, which in this case, we are going to be pulling this SNMPO ID, and we specify all the parameters required for it. Throughout this presentation, we're going to try to show you several of the EM script triggers available. However, if you want to read more about this, as well as EEM in general, please be sure to check out the reference slide for this presentation that is going to be available on the Cisco Events app. Now, circling back to our example, once we have specified the trigger for the EM script, we can then move forward with the action blocks. We will always be identified by the action keyword, followed by this value. And this value will set the order in which the instructions are going to be carried out. Now, here I want to stress out the importance that these values are not sorted numerically, but rather alphanumerically. So whenever you write your own EM scripts, you need to be very wary with your naming convention. Our suggestion is to use padded zeros at the beginning before the number itself, so that way you always ensure that your EM script is going to run exactly in the order that you intended it to. And additionally, I would personally suggest to you to consider using increments greater than 1 by 1, like for instance in this case 10 by 10, so that way if you later on need to add an additional action that was not planned at the beginning, you can just, in between two already existing ones, you can simply go ahead and add it, without needing to renumber all of the remaining actions. Once you have specified the order in which the action is going to be carried out, the next step would be to define the action itself, which here at TAC, most of the times we're going to be using CLI commands as well as syslog messages. But again, these are not the only options available. And we provide as well all the additional required parameters for it. So we've already specified that we're going to be running a CLI command. Now we specify which command are we going to be running. Now, let's take a closer look. This may sound nice in theory, but let me give you a more practical example. Let's say that we have two routers, router A and router B, in which we are seeing this EIGRP neighbor that is going down on a daily basis. We don't know why it's happening, and more concerningly, we don't know when the issue is happening. So it might be an issue that's hard for us to troubleshoot right as it is taking place. So we can come up with an EM to think of as a solution in order to investigate a bit further the task at hand to try to narrow down that root cause. So we can perhaps use as our starting point or as our trigger this EIGRP error log that we see whenever the neighbor is going down. As you can see here, we see that the neighbor is going down, so we know that we can then carry out a set of instructions on the EM script to collect further information. Now let's say from our previous troubleshooting, we already have a packet capture running on the background that is saving information on all the packets incoming into the router. So we can then think of using this EM script in order to perhaps stop that packet capture to get the latest the information on the latest packets going through the router, as well as collect like additional show commands, either related to EIGRP, which is obviously the issue at hand, but as well about the CPU or perhaps any additional information on the router. So once we have that idea, we can sort of come up with the actions that we would need on our EM script. And the final step would be to ever tweak it so slightly to modify it so that we save that information. And we can save that on different text files, or in general, files at all. Like for instance, the packet captures, maybe save it as a PCAP file that we can then later on retrieve from the router and perhaps load onto an additional tool like a Wireshark, for instance, and save all the show commands, like for instance, also as well to a text file that we can then retrieve and take a look at it, let's say with a notepad or something like it. Now let's take a look at it from the code side so you get an idea of where I'm going at. Here you have an example. Let's say this is our packet capture that's running already on the background, that it's saving information on all the latest incoming and outgoing packets onto the router. We can then think of something similar to this as an EM script. Now let me break down each instruction so you understand exactly what is going on here. So first of all, we're going to be using this holding time expired as our trigger for EM script. So whenever we see that error log, we know that the EM script is going to be run. Now, here I do want to take a couple of seconds to emphasize the importance of whenever you're writing your own EM scripts, about the triggers. The reason is if your trigger is too broad, it might happen that your EM script might be triggered multiple times, or at times when you're not wanting to issue or troubleshoot that particular issue. And so that might get either a lot of information or perhaps overriding already existing ones. And counterwise, if your trigger is too specific, it might also happen that it's so specific, the issue, that you never save you never encounter it again, and thus you never save that information, and then you don't have any information to troubleshoot your issue. So the best way is to meet somewhere in the middle where it's as specific as you possibly can for your issue, but without being too overbearing. Once we have specified the trigger, we can then move forward with the action blocks itself, starting with the enable command. The reason why we want to start with the enable command, or it's a recommendation from our end to start with the enable command, is that a lot of the show commands or the tools that we want to either start or stop might not be available unless we are running in privilege mode. So it's a good practice to always issue first the enable, so that way we ensure that all the remaining action on the script are going to be carried out successfully. And like so, in this case, once we have the enable command, then we can move forward with the action, which in our case, our main concern is stopping that packet capture that we have already running in the background, as well as collecting some show commands regarding the EIGRP, as well as the CPU on the router. If we check the perspective and take a look at it from the router side, we would have something similar to this. So first of all, we're going to be seeing this EIGRP neighbor that is going down. Again, this is expected, it's what we were using as our trigger for our EM script, so we are bound to see this error log. And immediately afterwards, what we're going to be seeing is this error log informing us that there's an EIGRP flap that has been detected and that the EM script run. If you notice from our previous slide, this is a syslog message that we previously configured on our EM script as our starting point. So we know for a fact that whenever we see this error log, the script is running. And so information is being saved on the background. More importantly, the packet capture is being stopped, and all that information is being saved. So after a short period of time, the expected outcome is to see on the boot flash two separate files, one containing the pcap file that will contain the latest information on the packets going on the router, and as well as the text file that will contain an appended version of all the show commands that we issue. As you can see, this is only just a small example of what you can achieve with an EM script. But what if I told you that we can take this even to the next level? With some coding skills, we can combine an EM script with a Python script so that we can further enhance your data collecting process and expedite your network troubleshooting. Let me pass the microphone back to you, Jeff, so that you can walk us through on how we can achieve this, and more importantly, what are the benefits of doing so.
Thank you, Arturo. Now, as we've seen, EEM scripts give a powerful built-in tool that's already built into iOS XE that you can use to troubleshoot these events when they're happening. But perhaps you're more familiar with programming languages such as Python. Maybe you want to be able to process the data you collect or interact with an external API. We can do these things with Python, and the way we can deploy Python on these networking devices is to use the guest shell. The guest shell is a lightweight Linux container based on the CentOS distribution. It's deployed using the IOX framework, which is available on all of our iOS XE switches and routers. Now, before we get into the guest shell, there is some configuration you may want to do first to allow the guest shell to be able to communicate out into your outside network. This will make it much easier to be able to move scripts onto and out of the guest shell, allow you to interact with any external API that you want to, and so on. So the first configuration we'll look at is the IOX configuration. Here we can define the app VNIC, which is the VNIC that's going to act as the gateway from the iOS XE host into the guest shell, and that's going to be virtual port group 0. The guest interface 0 corresponds to Ethernet 0 inside the guest shell. We can also give a guest IP address here, which is the IP address that will be applied to Ethernet 0 inside the guest shell. We're also going to give the guest shell a default gateway so that it knows where to send traffic. And finally, under this configuration, we can define a name server so that the guest shell can resolve host names. The inside interface from iOS XE is going to be virtual port group 0, and we're going to put that into a VRF to keep the guest shell traffic separated from normal traffic on the device. The outside interface going into the outside network is going to be Gigabit Ethernet 1, and that's going to be the outside interface. And in order to allow the communication from guest shell into the outside network, we're going to use NAT. This NAT configuration is probably similar to what you're used to. We're going to have virtual port group 0 as the inside NAT interface and Gigabit Ethernet 1 as the outside NAT interface. We'll make an ACL to define the IP addresses on the inside interface that we're going to translate. And then we'll finally apply NAT overload on the outside Gigabit Ethernet 1 interface. Finally, in order to allow that translated traffic to then be sent to the next hop off of Gigabit Ethernet 1, we need to define a static route, and we're going to put the overload keyword at the end of that to allow the traffic from the guest shell VRF to be routed out Gigabit Ethernet 1 on the global routing table. Now, inside the guest shell, well, first, to enable the guest shell, we use the guest shell enable command. Then, if you need to destroy the guest shell for any reason, the guest shell destroy command will do that for you. We can access the guest shell once it's been deployed using the guest shell command. By default, we enter the guest shell as the guest shell user, but we do have sudo permission and can switch to the root user if you wish to do so. Inside, it's a normal Linux environment running on the bash shell. All of the commands that you're probably used to are there. If you run ifconfig, you'll see the Ethernet 0 has the IP address we configured on the previous slide under the IOX configuration. And if you have outside internet access, you can also ping outside websites such as Cisco.com. Now, this is a container, so there is limited interaction between the guest shell and the underlying iOS XE host. However, there is a built-in API that allows interaction to occur. From the guest shell's perspective, we have access to the do host command, which allows us to send CLI commands to the underlying host and get the returned output. And then from the iOS XE host perspective, we have access to the guest shell run command, which will send that whatever command you get, give it to the bash shell and the guest shell, and return the output to you. Now, because this is a container, there is limited access to directories between the two devices, but there is a shared directory in the boot flash guest share directory. This makes it easier to move files between the host device and the guest shell if you wish to do so. Now, the Python comes pre-installed on the guest shell from iOS XE version 17.3 onward. That will be Python 3 by default. If you wish to install a different version of Python, the yum utility is available inside the guest shell, so you can use yum install to install other utilities such as other versions of Python. Now, Python comes pre-installed with several modules inside the guest shell, as you can see here. If you need any help with these modules to understand what they do, from the Python interpreter, you can use the help command and that with the module you want to know more about, and that will give you a text output describing what that module is and what functions it makes available to you. Additionally, we can install additional libraries that if you want to use one that you don't see here, using the pip install command. Here we use pip3 install to install Scapy to get additional packet generation capabilities inside the guest shell. Now, one of those modules that's made available to us is the CLI module. This is going to allow us to send commands to the underlying host device and interact with it. One of the functions available to us is the configure module. This allows us to send configuration commands to the underlying iOS XE host. Here we send the host name command to change the host name of the device. But since this is Python, we have access to all the powerful tools of Python, such as conditional statements, loops, variables. So in this example, we use a loop to build several sets of strings of CLI commands. And then in this following loop, we send them consecutively to the underlying host device. Now, it's similar to as if you were in config terminal, so you'll have to send the commands, like you'll have to enter the interface, configure the IP address, enter the next interface, configure the IP address, and so on. And as you can see, this loop would result in those 3 loopbacks being assigned their IP addresses. We also have access from the CLI module to the execute function. This allows us to send show commands to the underlying host device, and the output is returned as a variable, returned as a string that you can then store in a variable for further processing if you wish to do so. This is just a simple example where we take that output from the show processes memory platform. We just use a for loop to loop through it and print the returned lines, but you could do what you want to with that returned output. You could process it to get specific output that you want, store it into a file. It's Python, so You have the flexibility to use it however you want to use it. Now, as we've seen, using Python in the guest shell gives us additional capabilities to interact with the underlying host device. But Python by itself doesn't have the ability to be triggered when an event occurs. To achieve that, we can combine Python and EEM scripts, and I'll show you in this example on the next slide. Say you have a syslog that you want to get more information about. In this example, we're going to use a high memory syslog that begins with platform 3 element critical. So we're going to define an EEM script that uses the syslog event to trigger when we see that high memory event. And every time we see that, it's going to run this EEM script. And as a part of this EEM script, we have an action to use the guest shell run command to run our Python script. In the Python script, we're going to run the CLI execute command to get the show process memory platform sorted and store that into a variable. Next, we're going to open a file in that shared boot flash guest share directory. We're going to open a file there and we're going to append to it. Next, we're going to take the show clock output, append that to the file so we have a nice timestamp for when this occurs. And then we're going to go into a for loop. We're going to take that data that we collected in the variable. We're going to go through it, get the top 5 memory users, the amount of memory they're using, and we're going to put that into that file. The end result is a file that for every time we see that memory log, we're going to have a timestamp and the top 5 memory users with the amount of memory they're using. This gives us a convenient file to be able to look through to see how memory use was changing over time. Let me give you another example. We in the TAC often ask you to upload lengthy outputs to our service requests, so it might be nice to have a Python script that could do that for you. Here we have a Python script. We're going to set the URL. We're going to use the cxd.cisco.com file transfer server. We're going to set that as our URL. The username is going to be the service request that you want to upload the data to, and we're going to get a password. That password is going to be a token from Support Case Manager. If you go to the Attachments tab, there's a Generate Token button, and that token that's generated there will be the password we're using here. Next, we're going to make a file name. Here we're just going to use showTech, and then we're going to use the datetime module of Python to give it a timestamp so we know when this output was collected. And then finally, we're going to send an HTTP put request to send this data to cxd.cisco.com. And as a part of that, we're going to use the CLI execute function to get the showTech output. So that showTech output would be run on the underlying host, and the string will be returned and sent automatically as a part of this HTTP put request to cxd.cisco.com and automatically uploaded to your case. Now, for this example, we used a fixed output for a showTech, but it would be simple to modify this to take a command line argument to grab whatever output that you want to upload to a case. Now, as you've seen, these tools provide a powerful tool that allow you to automate data collection on your devices and are going to enhance your ability to troubleshoot issues and collect data about these issues when they happen. Further, these are flexible tools, and I also want to challenge you to think about how you can use these to enhance your troubleshooting capabilities in your network even further. I'd like to take this time to open the floor for any questions that you may have. XR?
I believe so, but we will need to check out the specifics. But I believe, yes, it is supported.
So, yes. So he asks if the EEM scripts and guest shell are available in iOS XR. I don't know off the top of my head. On our team, we usually work with iOS XE, but we can go over to the XR booth with you after this, and we can check with them. Does anyone else have any questions? The question is, do we have a library of examples for EEM scripts and Python scripts? I don't believe we have a library of examples for Python scripts, but we do have a reference slide that goes to a document on EEM scripts, and it has some commonly used EEM scripts if you want to look at that. That's a hidden slide, so you can access these slides from the Cisco Events app.